Hello everyone and welcome back to the Deep Learning playlist. First of all, I'm really sorry for the delay in order to upload the tutorials. I've been really busy with my office work and now it is becoming really difficult for me to create a balance between my full-time job and the YouTube work that I've been doing. But still, I'm trying my level best to create as many tutorials as possible in order to complete this playlist, because going ahead I am also planning playlists on topics like NLP, pandas for data analysis, NumPy, and topics based on generative AI field as well. So please consider showing your support if you are new to the channel and you are not yet subscribed. It will motivate me a lot. Anyways, coming back to the topic, from this lecture onwards, we are going to start a discussion around CNN, and I'm planning to create around 6 to 8 tutorials in order to cover the entire concept of convolutional neural network to provide you an end-to-end understanding on this topic. So let's get started with the first question, that what is CNN or convolutional neural network? If you will do a simple Google search, then it will tell you that CNN is a kind of network architecture for deep learning algorithms, which is specifically used for image recognition and tasks that involve the processing of pixel data. In simple words, when you have images as input, over there you will need a special type of architecture. So the typical architectures that we have been studying so far, like ANNs or other machine learning algorithms, will not help in this situation where you are dealing with image data. You will need a special type of architecture that should have the capability of capturing the patterns or features available in the images. And this is where we need to have an understanding around convolutional neural networks. As you can see, it is a type of artificial neural network which is used mainly for image or object recognition and classification. And within this particular playlist, we are going to understand in a lot of details that how this special type of architecture or neural network actually works in order to interpret the image data. And this is how a convolutional neural network architecture looks like. But at the moment, if the topic of CNN is new to you, this will not make sense at all. And it is absolutely fine, because this is the purpose of creating these tutorials, so that I can explain you these topics or architectures from absolute basic. So for the time being, if terminologies like featured map or pooling layer, these things are not making much sense to you, it is absolutely fine. Leave it there, because we are going to have a dedicated lecture for each of these topics. But let's try to understand from a really high level perspective that what is actually happening with the help of a CNN model. So basically you will have an image like this, like we have over here for the Tweety bird. This image will be then passed on to the CNN architecture that we have over here. And this architecture will perform some operations, some tasks that we are going to discuss ahead within this playlist. So for the time being, you can skip that part. And as an output, it will give you the probability of the image class. So is it going to be the image of Donald Duck? It is not that confident about that. Is it the character Goofy? So again, the probability is really less, but the architecture is able to identify the image as Tweety bird with a really high probability of 0.7. And going ahead, we are going to have a lot of fun understanding that how this CNN architecture is able to perform this task. So the upcoming 6 to 8 tutorials is going to be all about this, understanding or interpreting the CNN architecture. And before we move ahead with the discussion, it is really important that at this point of time, we should have a very clear understanding around pixels. Most probably, majority of you guys will already have a detailed understanding around what are pixels and how they contribute in order to form an image. But even if you're someone who has no idea or no clue around pixels or the concept of pixels, then let's take next few minutes in order to understand that. So basically, pixels are nothing but the building block of any image. You can understand it like this. The way an entire house is built by stacking bricks over each other or side by side, exactly the same way, any image or video that you see on your electronic device, whether it is a mobile phone or your laptop, that image or that video is basically made up of lots of pixels. Going by the definition, pixel is the smallest element of an image. The value of the pixel image will range between 0 to 255. In case this particular definition is not making much sense to you, then still it is fine, because this is why I have taken this image sample over here in order to provide you a proper breakdown or interpretation of pixels. So we have three images over here. This is first, this is second, and this one is third. On the first image, if you pay attention and look very carefully, then you will be able to understand that it is a very hazy image of a human face, because you will be able to identify some features like eyes over here, then maybe a nose right here, and most probably some hair on the head. Although this image is not detailed at all, it is extremely hazy, and it is just because the resolution of this image is really small. Now, you may have heard about this particular thing, that if a resolution of a particular image or video is high, it will be in HD, in high details, and if the resolution is really low, then the picture quality of that image or video will be really poor. And the resolution of an image or video is majority of the times mentioned like this, maybe 320 multiplied by 240 for a small image, or maybe something like this, 1080 multiplied by, let's say, 1240, something like this. Now, what does this particular thing mean? It means that if your image has a resolution of 320 by 240, then it means that it has 320 pixels horizontally like this in order to form the image, and 240 pixels aligned vertically like this. And the higher the number of pixels you have, more HD your photo or video will be. And let me quickly erase all this, and let's come back to this topic of picture 1. You will be able to see these small blocks like this one over here, then this one over here, then 3, and then 4. These are actually pixels, which is actually forming this entire image. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, or maybe 13. Not 13, actually 12 pixels horizontally and 16 pixels vertically. So within each column of the image you have 16 pixels, and within each row of the image you have around 12 pixels. And this is how lots of pixels combined together will form an image or a particular frame of a video. Now, the second thing that we need to discuss is this particular picture that you can see, the picture 1 I'm talking about. It is a grayscale image, which means it is a black and white image. So you will have pixels which are absolutely white or maybe absolutely dark, or few pixels will be gray. But a computer that understands nothing but only numbers or integers, how exactly it is able to understand these colors or the intensity of colors? It is because behind each and every pixel there is a value attached to it, and this is where we need to shift our focus to the image number 2. Pay attention very carefully and you will notice that the brightest pixel will have the highest values. Like this one has a value of 204, this one being the brightest has the value of 255. And since we have already learned this thing within the definition itself, that the value of the pixel will range always between 0 to 255. This is why the brightest pixel or the pixel which is absolutely white will have a value of 255 or very closer to 255. Similarly, if you will try to notice the darkest pixels which are absolutely black, those values will be very close to 0. Like this one, it has a value 6, then this one has a value of 1, and this one which is entirely black has a value of 0. And the grey ones will have a value almost between 0 to 255, like this one, very close to 150. Okay, so far I hope that you have a decent idea around how pixels are forming an image and how each and every pixel has a value attached to it. And the picture on the absolute right hand side, which is picture number 3, is nothing but a two-dimensional array of numbers, which is telling you that how the computer will see an image. So this is a very interesting stuff that you should know, that picture 1 is something that how we as humans will interpret an image, and we will try to understand that okay, this picture is actually representing a human face. But in contrast, computers do not see images like this, the way we see an image, a collection of features like eyes, nose or mouth. In fact, what a computer will see is nothing but an array of numbers. This array could be two-dimensional or three-dimensional as well. And since this is the way of computers in order to interpret an image, we required a special type of architecture that will make the computers understand that even if it is interpreting the image in this particular way, still how we can make it efficient in order to make it understand that okay, within this area you are going to have the eyes, or let's say within this particular area you are going to have the mouth on the human face. So I hope that so far you have a decent understanding around the pixel-wise representation of a grayscale image. Now some of you may have this question in your mind that if this is the representation of a grayscale image, then how exactly behind the scene a colorful image is being represented? So without taking much time over here, I will try to cover that part as well really quick. First of all, in case you are already not aware, then you need to understand this thing first, that whichever color you see on your computer or mobile screen, within the combination of thousands and millions of colors, all those colors are being formed with the combination of only 3 colors, which is red, green and blue. And when we were decoding a grayscaled image like this, the computer will be able to interpret it with the help of a 2-dimensional array like this. However, in terms of a colorful image, the computer will have 3 sheets like this. First will be like this, second will be like this, and third one will be like this. The first sheet on the top will represent the red channel, second one will represent the green channel, and the third one will represent the blue channel. And the resolution for all the 3 sheets will be the same. So let's say if we are talking about a resolution of 32 by 32 size of image, all these 3 channels or all these 3 sheets will have the same resolution of 32 by 32. And going by the combination of the value for each and every pixel on the image, combining all the 3 channels together, our computers or electronic devices are actually able to render multicolor images or videos on the screen. So I hope that now you have some clarity around the interpretation of a colorful image as well. For the time being, this much understanding around pixels is good enough in order to move ahead with the discussion of CNN architecture. And before I try to provide you the basic intuition around a CNN architecture and how it actually works, we really need to raise a question that why can't we use artificial neural networks or ANNs that we have studied previously within this playlist? Why not use that particular architecture of ANN instead of CNNs? So let's try to understand that thing first. The thing is that you can obviously use ANN for tasks like image classification. In fact, if you are using ANNs to do image classification on data sets like MNIST dataset or similar kind of any other small data set, then even ANN has a very good tendency of performing well on the data. However, CNNs or convolutional neural networks always comes up with better results, or you can say better performance. And using ANNs for your image data will have a lot of disadvantages, or you can say limitations, that we will try to understand one by one over here. The first limitation that it has is high computational cost. So when you are using an ANN architecture in order to do image classification, this becomes computationally really expensive. Let's try to understand this particular point in details. So let's consider this particular image, and let's assume that the size of this image or the resolution of this image is 30 by 30. Although it is not, but let's just assume. Okay. So previously, when we were working with artificial neural networks or we were understanding ANNs, the input data was totally different from an image. So you know that within ANNs, each and every node will be connected with each other, something like this. Okay. And the data we were passing to this particular ANN architecture was an array of numbers like this. Okay, that was not an image data. However, this time we do not have any relational data in order to pass on to this particular architecture. So let's try to understand that how we are creating the input data out of this particular image that we are assuming with a resolution of 30 by 30. So the first thing that we will do, we will take this first row of pixels which is there on the top of the image, and we will stack it like this, something like this. Okay, and since it is going to be a 30 by 30 image, this particular stack will have 30 integers or 30 values like this. Similarly, we will take the second row of pixel and we will place it at the bottom. So again, it is going to have another 30 values like this. And the same way, you will have to unpack this entire image. You will take the pixel by pixel values and you will keep on stacking it vertically on the top of each other. Since the size of the image is 30 by 30, and therefore finally you are going to have 900 input values. And now let's consider that the input layer of your artificial neural network has 100 perceptrons or neurons. So within the first layer itself, you will have 900 multiplied by 100 equals to 90,000 weights to train. This is only within the first layer of your ANN. So for the time being, we are not at all talking about the hidden layers. So you have such a large number of parameters to train with an image of such low resolution, which is only 30 by 30. And now just imagine, what if you have a data set where the image resolution is really high? Let's say something like 600 by 800. In that case, you can only imagine that how many trainable parameters you will have in the first layer and how many trainable parameters you will have within the entire ANN architecture. So this is why it becomes computationally really expensive in order to train the ANN architecture for image classification. The second problem that you will face when using ANN for image classification will be overfitting. It is because if you have 900 data points in your input data, then going by the fundamentals of artificial neural networks, you already know that each and every data point will be connected to each and every perceptron of your input layer of the ANN, and each and every connection will also have the weights assigned to it. So when you are training an ANN architecture for image classification, you are going to have a dependency on huge number of weights in order to do the image classification. As you can see, on the input layer only, you have 90,000 parameters or weights to train. So the dependency is really high because it is trying to capture each and every minute details, and this will definitely lead to overfitting. So what I'm trying to say is, if you are trying to train your ANN architecture, let's say on this particular data, then it will minutely learn the position, pattern or feature of this number 8. So let's say in the image you have the number 8 located like this. And in order to learn the patterns or edges of this particular image, the ANN architecture is dependent on a huge number of parameters, which means it is learning the position or pattern of this number 8 so minutely that if in the next image, let's say you have the number 8 situated like this over here, then due to the issue of overfitting, the model might misclassify this particular thing. And this brings me to the next limitation or disadvantage of using ANN model, which is sensitive to the location of an object within the image, because it won't be able to deal with the variations of the image or the distortions. Try to understand, in the picture, let's say if you have a human face like this, okay, let's say you have some hair on the head and then eyes and nose and face, and we have this particular image in a 2D representation. Okay, then after unpacking this particular image row by row of the pixel and stacking it like this, it is losing the information of the spatial arrangement of the image or the object of the image. So when we have a 2D representation of an image like this, there is a relation between the position of these eyes with respect to the nose, with respect to the mouth. And capturing these relations on the object, we are able to identify it as a human face. But this particular information gets lost when you are flattening the arrays of the pixels like this. And this is where your ANN architecture will struggle a lot. So I hope that you are now able to gain a decent understanding that why using ANN architecture is not that good option due to all these limitations that we have been discussing so far. And what was the need of developing a new architecture like CNN. So let's move ahead and try to learn that how CNNs are able to tackle these limitations or how it is able to perform relatively well. So over here we are going to gain a very basic intuition around the CNN architecture and how it works. So mind it that we are not actually interpreting this CNN architecture exactly, okay, because we will do that in a separate tutorial in a dedicated lecture. However, for the time being, we are going to understand that as a whole, what exactly this CNN architecture is doing in order to interpret the image data. So for a moment, let's forget about CNNs, let's forget about the topic of deep learning, and on a human level, let's discuss that how are we able to identify this digit 8, or if you will be asked to explain a child about the properties of a digit like digit 8, then how exactly you will make him understand. Maybe first of all you will try to explain the child that how to draw a circle with the combination of different edges like this, okay, and then another circle with a combination of different edges like this, and then you will try to explain him the relation or the position of these two circles being placed on top of each other in order to form the number 8 like this. And then maybe you will try to explain him about the variations or distortions. Maybe you will try to explain him that not necessarily the size of both the circles has to be the same. The number 8 can also look like this, or maybe look like this. It can be also tilted like this, but in all the cases it is actually number 8. And finally, after a lot of practice and going through after a lot of examples, the child finally learns that how exactly the number 8 looks like, what are the exact patterns, edges which are together forming this entire digit. And the CNN architecture also learns about a specific object or a specific image in the same way. Let me try to explain you how. So basically, the CNN architecture works in different layers like this. So my drawing is not that good, so please try to cooperate with that. Alright, so the first thing that a CNN architecture will try to do, it will simply try to learn about the edges like this, okay, like this, maybe like this. So in terms of deep learning or CNN, these are actually called the primitive features, these small and minute edges which are actually forming the image. So in the first layer, once we are done learning about these small images or the primitive features, in the next layer we try to identify or learn about more complex features, like how using this and this primitive feature, a semicircle is drawn like this, another semicircle is drawn like this, okay, maybe one like this, one like this, okay. And as you move ahead to the next layer, it finally starts learning the actual feature or actual pattern of the object within the image that you are trying to make it learn. Now at the moment, there are few terminologies that we need to get comfortable with. First is these small edges. These are the primitive edges. These are actually called primitive features, and these primitive features will going forward will form more complex features like this one on the top, this one at the bottom, okay. So that will be the full-fledged features of the object. These layers that we have, this is layer 1, this is layer 2, these are called convolutional layers. And going ahead with this playlist, we are going to have a dedicated lecture on convolutional layer in order to understand that how it actually works, what is actually happening behind the scene in order to capture these primitive features or the complex features of the object. These structures that you can see over here for each and every layer is actually called filters, or you can call it feature maps, and the operation happening on each and every layer is called the convolutional operation. So it is called convolutional operation. It is still okay if you tend to forget these terminologies, because anyways we are going to cover all of these in a dedicated tutorial for each one of them. But for the time being, I just hope that you have a really basic understanding around the intuition for a convolutional neural network. Again, just to summarize everything quickly, if a CNN architecture is supposed to capture or learn the patterns of this particular image, it will start by learning the primitive features like this, where it is trying to detect the edges, the very small features, tiny features. Going forward in the next layer, it will try to understand that how these primitive features are combining together in order to form more complex features. And towards the final layer, it actually starts learning that how actually the object looks like. And finally, let's close the discussion by having an understanding around the applications of CNN. Because if you are learning a particular technology or a particular architecture, you really need to understand that what actually are the applications or uses of that particular technology which you are learning. So the first thing is the CNN model is able to do image classification with a probability value. Like we have seen on the top itself, we passed an image of a Tweety bird, and finally in the output layer, it created the probability of characters like Donald Duck, Goofy and Tweety, where Tweety bird had the highest probability, which means it can say with lot of confidence that the input image we have passed on to the architecture belongs to the Tweety bird. Secondly, it is able to do the object localization with a bounding box. So that thing looks something like this. If you will have a look on these examples, on the image, the CNN architecture or the CNN model is able to identify all the car objects with the help of a bounding box. And this kind of technology is used a lot in data science projects based on traffic or even with self-driving cars as well. So this is another example where the model is trying to capture all the car objects within a given image. Third application could be face detection. So back in days, there was a time when we did not even have cameras in our mobile phones. And nowadays, you can unlock your mobile phone by simply showing your face to your phone screen. That is another interesting application of CNN architecture. And it is also able to perform tasks like image segmentation. So I will try to show you an example of this. So the task of image segmentation looks something like this, where in a given image, the model is trying to capture the area covered by one specific object. Like you can see, the area covered in red is representing all the people or all the humans in the image. Similarly, the area covered in blue is representing the vehicles or car objects within that particular image. So this is another cool implementation of the CNN architecture. So I hope that you were able to learn a lot of things with the help of this particular lecture, starting from the applications of CNN, basic intuition of CNN architecture, the idea of the difference between ANN or CNN model, the basic understanding of image fundamentals or pixels, and CNN as a whole. Going forward in the upcoming lectures, we will unpack this architecture and we will understand each and every component of this architecture in details. We will learn about convolutional layer, we will learn about pooling layer, feature maps, strides, a lot of things. So please consider subscribing to the channel. Also press the bell icon along with that so that you can get notified every time I am uploading a new lecture. My name is Vikash. I thank you very much for watching till the end, and hopefully I will see you in the next video.